Hello, hello, hello. Welcome to the Fundamentals of Programming. Today we're going to be talking about defining functions. Now, we've been using functions for quite some time now without us probably realizing it, but we have never actually defined our own function. So we're going to talk about that today. First off, let's go ahead and talk about what even are functions. Now, functions take an input or an argument, do something to that inputs, and give us an output. So if we thought about a function machine here, we would take in some inputs, like those could be numbers or strings or whatever. They're going to do something to those inputs and give us an output. So this function, what's inside of here, is what we get to define today. We're going to define what actually happens to these inputs and what we get out. So we've been using a couple functions, and some examples would be like the input function, where we are taking in an input from the user and then storing that as a variable, or the print function, where whatever we put inside the parentheses is what is printed to the output module, or things like data conversion, where we have a string converting a data type to a string. We put a non-string data type inside of the parentheses, and it's then converted to a string. So those are all examples of functions where we have an input, something's done to that input, and we get an output. So those are all functions. Now, the reason we even use functions in the first place is we don't have to repeat our code this way, right? We don't have to define what str does or how to convert from a converted integer to a string or a string to an integer. We can just use the function that is defined, and it performs that code block for us without us having to type it out every time. So it allows us to kind of be a little lazy, which I'm sure a lot of you appreciate. So functions kind of enable us to be a little lazier, but it requires some work up front. So just to really talk about this, functions are just predefined pieces of code that, when called, perform an action and manipulate this data. So that's just another way of rephrasing what a function does. So that's a function in a nutshell. But today we're going to talk about how we define functions. So let's get to that. So defining our own functions. Now there's 5 components, and I have this little image over here, and I'm going to walk us through where each component is. So every function is composed of 5 components. The first thing is the definition keyword. So I'm going to highlight things as I go through here. So here's the definition keyword. And that just stands for definition. So that indicates the compiler that we are now going to be defining a function. The second thing is a function name. So that in this case is going to be, let me change the color here, large XY. So we've got our function name, the definition keyword, the function name, and then after that we have arguments placed inside of parentheses. So we have 2 arguments in this case, x and y, and I'm going to highlight both of these, and notice they are placed inside of parentheses separated by a comma. So these are my arguments that are going to be passed into the function that are then manipulated inside of the function and used, right? So these are my inputs, essentially. These are my inputs in that image that we saw before. Now, after that, we can't forget our colon. We got a colon, don't forget it, otherwise you will get an error. And then on the inside, we have our code block. And this is what the function actually does. In our case, we are saying if x is less than y, or x is greater than y, print x, else print y. So we're determining whether x is greater than y, and this is my function named large xy is just giving us the larger of the 2 numbers. So this is my function definition right here. Again, I have the definition keyword, a function name, arguments, or I can also have functions that don't have arguments, but that just do something. But most of the time we're going to have inputs into our function. And then those inputs are used inside of the function. Notice x and y are both used in my code block here, and I am actually just printing x and printing y. So, depending on whether x is greater than y or not. Now that's the definition of our function. If I just left it at the definition and didn't actually call the function, nothing would happen. So I actually have to call the function after I define it. So this would be above our function, and then if we went over and called the function, I'd maybe declare 2 variables, a equals 1 and b equals 2, and then I say large xy, which is my function name. I'm calling my large xy function, and then I put in as inputs a and b. That's going to, so a would be x in this case, and b would be y. Then it's going to give me the output, which 2 is greater than 1, so I'm going to get this, print y, which would be 2. So notice that these arguments, when I use the function, are different than when I define the function. And that's common practice. Don't actually, when you use the function, don't pass x and y into it, because that is going to, you're redefining a local variable which is going to can cause some issues and is just bad practice. So I could have just also typed in large XY 1, 2 here instead, and it would have given me the same result. So I'm just passing arguments into here. So that's the basics of a function, and this is a very simple function. So let's look at another example of defining a function. So this is another simple example. I'm going to go ahead and go to my Replit compiler here. And let's go ahead and say that I am going to, remember I need the definition keyword, and I'm going to create, so this function adds an exclamation point to a string. So if I say define, I'm going to name this exclaim. I'll spell that right. So exclaim. Now this is the name of my function. I'm going to pass into it a string variable. So string variable is my variable I'm passing into it. And notice this argument, actually, the name of it doesn't really matter outside of the definition. So inside of this, I'm just going to say print string variable plus exclamation point. So now all this function does is we give it a string variable on the inside, it uses it, and adds an exclamation point to it. So now if I say exclaim congratulations, it's going to just add an exclamation point to that. I could also store, I could say greetings equals aloha, and now if I pass the greetings variable into my exclaim function, it's going to take what greetings is storing and add an exclamation point to it. So I get aloha instead of aloha. Slight difference, right? It's an exclamation point. So that's another simple example here. Let's take a look at another more complicated example. Let's take a look at this code. So I have list1 here, which is a list of numbers, and it's, if you recognize it, that's the part of the Fibonacci sequence. Anyways, what I want to do with my code here is I want to add up all of the integers together to get one total sum. Now, notice I haven't actually defined a function here, and this is pretty common. I might define what I want done before I actually define the function itself, because I might say, oh, I only need this once, but then you realize, oh, I actually want to do this a bunch of times, so you might then go ahead and define it as a function. So let's go ahead and see how I would do that. But first, let's see what this function even does. So I say total equals 0, which is the variable that stores my sum of integers. If you remember from the previous video, this is kind of like adding up the total sum in a range. Except for in this case, we're going to use the len function, which is going to give us the length of this list, which is just the number of items in this list. So there are 10 items in this list, so x is going to go from 0 up to 9, which is convenient because 0 is the first index and 9 is the last index. So it's going to go, x is going to go up all of these ranges, which is super nice. So it's going to go ahead and increase as we go through here all the way up to the last range. I can use x now to grab each of the items, right? So if I say list1x, that's going to be, starting off, it'll be 0, so I'd grab the first item, then I'd go 2, or I'd go to 1, which would be the second item, then 3, which would be the third, or 2, which would be the third, and so on, because x is going to be my index in this case, which is awesome. So I'm going to go ahead and add that to my total variable, and it's going to change as we go through here, kind of like in the last example, which is super powerful. So now, how do I make this a function? So I've got a good start here, but let's go ahead and say I delete this variable, and I want to define this whole thing as its own function. So I'm going to say define list sum, which is going to be my name, which makes sense. And then I'm going to pass into it a list. I'll just pass into it list1 because that's already how I defined it. Now I indent this, add a colon, and I just defined my function. Notice I just took that same code, changed it up a little bit, defined a function, put it inside that code block, and boom, there we go. Now I could go ahead and say, I don't know, let's say I have, let's say weights. Let's say we're trying to figure out the total weight of something. Let's say there's 120, 100, 150, 160, and then we can say list sum and pass in the weights list, and we're going to get the list sum, right? So we get the total weights. I could go ahead and change this now. I could change the list itself and get a different number because it's going to automatically update. So this is pretty awesome. Now I could go ahead and let's say I want to add also the lengths together. So let's say I had 60, 20, 30, 90. And then I could go ahead and call this function again for that new list, lengths, and I can get both of those values. And then if I wanted to, the cool thing about this is I could actually, instead of saying print total, I could return total. And what this is going to do is this allows the function to return the value total as a variable. So instead of just saying list sum weights and printing that out, I can actually say that weight sum equals and height sum equals. Now if I hit run, nothing's printed out anymore. Notice with the return, nothing is printed out. However, if I were to say print weight sum, now I get that printed out. So the return statement allows me to return the value that I want. So I can return the total value and use that as a variable outside of the function, which is super nice. I could also then go ahead and say, I don't know, what if I wanted to find the average weight? So then I could go ahead and say weight average equals weight, I'll make sure this is an integer, int weight sum divided by, so weight sum divided by the length, let's make sure this is an integer too, length weights, and then hit run, and I get weight average, and I'll just go ahead and print weight average. So notice I can go ahead and then use this outside of my function and get the average weight, which is super cool. So I can actually go ahead and, I could even, if I wanted to, define another function for the weight average that might even use the list sum inside of it, which is super cool. So that's called functional programming, and try to keep it simple for now, but that's the power of functions, right? We can either print something directly from this function, or we can return a variable or value from inside the function. So that's really cool. All right, let's go ahead and summarize what we learned today. To summarize what we talked about today, let's go ahead and let's go get started right off of this. So functions take an input argument, perform an action on that input argument, and then give an output. This is common. You might see some functions that just do something. That's also pretty common. I didn't do any examples of that, but you could just have a function with empty parentheses when you define it that just does something. That's not uncommon, but I just didn't want to show any examples of that today. Number two, we can define our own functions very easily so that we don't have to repeat our code. Like when I did that last example with the list sum, I would have had to do that, copy paste that code with the for loop and everything multiple times to add up multiple lists. Instead, I can define the function once and use that any number of times, which is really powerful. Also, notice I had to define the function before I call it. That's a key point. I can't define my function after I call it because that just doesn't make sense. The computer wouldn't know what the function does. Also, arguments are variables that are passed into the function and only used within the function definition. So any argument is just for that function definition, and it's just irrelevant outside of the scope of that function definition. So don't try to use, if you defined a variable inside of the definition of a function, don't try to use that function or that argument outside of the function. You will just get an error. Another example that we just went over with the return statement is that it allows us to return a value rather than just print a value. So we could actually get a value out and store that value as a new variable, which is really nice, like when we did finding the average of a list. So that's really nice. And then finally, when the function is called, the input argument should not be the same variable name as when the function is defined. So if I named my input was list var, I don't need to name my whatever I'm passing into that function when I call it list var. It could be just a list, it could be list one, it could be weights, it could be average, it could be whatever it needs to be. And even I highly recommend that you make sure it's not the same variable name because it just is confusing. So make sure you go ahead and do some practice for this because functions are super useful, and let's start defining some functions. All right, happy programming.